In this video, I'm going to show you an example that is from Chapter 6 in Data Mining for the Masses, where it basically shows this example of how to do clustering. The whole objective of clustering is to try and find data points that are uh, very close together or very similar in groups that are together. And data points is sort of a technical term that could refer to basically customers. It could refer to products. I mean, it's basically the data that we have several attributes for. And we want to find out, are there various groupings of these that can be similar? From a customer standpoint, we often want to do that in terms of trying to segment our customers, but we find that clustering can be used in other ways. Now, I do recommend that you take a look at Chapter 6 in Data Mining for the Masses as you work through this video. The example and the explanation of the data is in there. I'm not going to repeat that, but just leave that for you to look up. But just like before, we have to bring in our data, and we already have a local repository. And so, just like before, we now need to import the data. And so, it's a comma separated file. I have already downloaded the file, and I put it here into my download folder. I do have to change it from semicolon to comma. And you notice our data starts looking weight, cholesterol, gender, and it starts looking much more meaningful in the way we would like it. We're going to go ahead and continue with this. And when we get down to here, we're going to say that this is Chapter 6 data. Okay. And I'm going to go ahead and hit finish. All right. And then I'm going to come back and hit our icon there to come back and bring us to our design view. And I'm going to go ahead and drag that data into our process. And as you notice, in this particular case, it automatically generated my tie to the results. The output from that went all the way to the results because there's nothing in here yet. Well, obviously we want to do some clustering, so we're going to have to bring in the operator for clustering. If I type in kmass, or k-means, I'm sorry, and we very shortly, you don't have to even enter the whole thing, we find that we can pick k-means, which is an example. There are a couple variations of it, but we're just going to bring the standard k-means in here, and if you notice we drop it in here, now we're going to have to reroute our data set as the input into the clustering. But at this point we could actually run it and we would be able to generate some clusters. Now I'm going to change this to 4, which is what to sort of match what the textbook has. And I'm going to add the other components in here, although you could go ahead right now and run this if you wanted. We're going to take defaults in terms of how the algorithms work. Just like with the decision tree, there's different types of parameters we can set here. My objective here again is just to sort of show you an example and have you deal with sort of getting familiar and comfortable with what are types of data and outputs that come from some of these types of algorithms. And so when we do our clustering here, one of the things the book pointed out that a way of getting the data and finding out and seeing your examples is we could put in here something called filter examples. Okay, and if we bring filter examples and we drop it down here, we can go ahead and take our other clustered set outputs it's allowed us to and bring it down here and take this into our examples. Now, the book had you go ahead and just run it this way and then sort of look at the output there. In fact, we're not actually going to filter anything here other than what we're just going to sort of use as a way to get, at this point, the outputs that we want. We're going to actually export our data to a file. And the reason is I want to sort of show you as we look at that output file what the data actually looks like that we get in terms of a result. And so we're going to go ahead and we're going to empty that. We're going to type in export, and pretty soon we'll find we have a write CSV. I'm going to go ahead and put that down here. And now I'm just going to change that routing to the right CSV. Now because I'm writing out a file, I have to give that file a name and so in a location. So I'm going to actually go ahead and put it with my downloads. Not probably the normal place to look at it, but it'll be easy to find it there. And so I'm going to go ahead and say output for chapter 6. All right, and I'm going to go ahead and say CSV for comma separated values. Now, you notice here it says a column separator. I actually do have to change it here from a semicolon to a comma so that our data comes out the way we want it. So I'm going to make that a comma, and now I can actually go ahead and potentially write out something. Except I notice as I look at this, I have a little red dot here, and there's something that is sort of missing here. And so, the input parameter, it says, is missing. So it doesn't recognize this connection for some reason. I'm going to go ahead and run it. And it actually is looking for me to provide a result, chapter 6. Result. Go ahead and run that, and we now have our model saved. That's the name of our model. Here's chapter 6 result. Probably not the best name, but we'll just live with it. Right now we have, just like we have in the book, we have 4 clusters that are created. As it points out, we can look at the centroid table here and sort of take a look. Now, the problem and the reason I wanted to export that file is the textbook sort of gives you a impression that to get the people in cluster 0, we could do a SQL query based upon these factors, and that's really, in a sense, a little bit misleading because we are trying to identify the clusters, but it's not that everybody that there won't be an overlap within the ranges, okay? And if you think about it, if this is sort of like if you did this on a scatter diagram in 3 dimensions, we'd be seeing the 3 sort of clusters of dots that would be close together. If we go ahead and we take a look at the Excel file that came out from this, let's see what we would find. So let's go into Excel, and let's go ahead and open up a file, and we're going to open a file from our downloads, and we're going to open the output, except whoa, it won't let us do that. And the reason it won't let us do that is because it is not liking me. Actually, it's not letting me open up any of these. So I am going to hit cancel here for a second, and I'm going to do file, import, and I want to import a CSV file, and I'll do it from the downloads, and now I can go get the data, and it is delimited, and it's delimited with a comma, and you'll see that if we go ahead and just hit finish here, I'm just going to put in the existing sheet. And the whole idea here is you can see now specifically for each of our rows which cluster they would end up in. Now I'm going to go ahead and sort this data, alright, and I'm going to sort it by weight, alright, and when I get done sorting it, we're going to take a look at sort of the boundaries between the conditions of some of the clusters. And so whoops, let's hold it up there. Go ahead and we'll sort it. We'll sort on. Okay, we went ahead and sorted on the weight, and you'll notice that cluster 0 is pretty much the weight, the weight. And if you scroll down here, and when we start getting to where the turn changes, you'll notice, however, that there is somebody with 169 pounds that's in cluster 1. Okay, and that has to do that it's really not just comparing just the weight, it's looking at all three data points. And what the k-means clustering algorithm does is basically looks at the distance between, if you sort of standardize these three attributes into an x, y, z grid, and went back to sort of Euclidean geometry, it would be looking at the distance between the points. And so, well, it is true indeed that 169 is, closer for many of the data points. What brings us to cluster 1 is the fact that the cholesterol number is actually lower. And so I just want to point out that you can't just assume that one of the attributes is going to be able to all on its own identify the cluster. In fact, you'll often have to do a different approach to sort of just like we had with our decision tree. Once we've identified that there are clusters, we probably all it really does is tells us sort of what things sort of are grouped together. It really doesn't necessarily help us exactly figure out how to pull them out without doing a lot of things. And often at this point we might go back and use a different method to try and then classify them into those clusters and to find out how could we classify those into those clusters. But I just wanted to point that out to you, and now let's go back over to our model. Okay, and so in our model here, we pretty much are done, and we have found basically what the textbook has found in terms of within the results. So a couple points though I did want to bring up that you'll need for your activity, and that is there's a couple other operators that you'll need to be familiar with. And we've got one where we're retrieving information, we've got our clustering, but what happens if we need to convert some data before we can actually process it? Okay, in our example here, all of our data is numeric. Well, the question is, what would happen if for some reason the data was not numeric? When it tries to, it's hard to do Euclidean type of, distance types of things when the attributes are not numeric. And so clustering requires the attributes it's trying to cluster around, they have to be numeric. So, I'm going to take and pause this for a second and change the data set. Okay, I've created another data set, and so I'm going to actually have to bring it into my repository. And it's basically the same data set that we had before, except I made a change to where gender was encoded 0 and 1. I basically have now changed it to be encoded with M or F. And so we're going to, if you see here, I now have F or M instead of 0 and 1. And so our data set here is going to function differently. And so now I need to chapter 6, and I'm just going to say alpha, so I know that there's some alpha data in there, and go ahead and say finish. Okay, now if I come back to my model and I bring that up here, and I'm going to delete the one I had, and I'm going to hook this up to my clustering algorithm. If I try and run this now, it's not going to work. Okay, it's going to say there's a non-numeric value because it really doesn't know how to handle F and M's in terms of what the distance should be for them. Now, um, yeah, in many ways, when you have uh, data that is, two values in there, it's really not necessarily a good technique to be taking categorical data and trying to use clustering with it. But there are times where um, it is done, and since your textbook did it, I sort of went along with it. But the point is, now we have some data here that doesn't fit. And so what am I going to do? Well, I have to take this data that's sort of nominal and convert it to um, something that's numeric. And so there actually is a uh, operator for that, and we're just going to make it go. We'll do nominal to numeric, okay, and we'll bring it in here. And so I need to convert the data before I put it in. So I tie this data here, and I'm putting this in between. And so when I have nominal to data here, all right, the question sort of is, well, what's it going to do? And I have to sort of identify, which value, what am I trying to change? And so, if I come down here to value type, and if it's nominal, I want it to just sort of take on some dummy values, and I go ahead and just run this again now. You'll see all of a sudden it looks like we have just like we had before. Now there is a slight difference if you look at the centroid table, in that we now have an attribute gender F, gender M as two different attributes, which are basically, hopefully they add up to 1, and it basically is the way it ends up showing how that data got converted. If we look at the file that got generated, now if you remember, we had in our model here, we generated a file that came out. Now, if we come and go back into Excel, which I still have open, all right, and once again, I have to import it. Output for chapter 6, get data, delimited. Okay. And you'll notice that I'm going to go ahead and I'm going to actually put the data, I'm going to put it in the same place. It doesn't like that, so I'm going to start it in column E, F, G. Okay, and I didn't start it at the top, but we can see our columns here. It's either going to be one of these is going to, 1 means it's F, or 1 means it's under this column. It's F0 means it's not an F, and obviously we have the opposite in this column. And so you can see the data is a little bit differently, but we basically end up with the same clusters, the same results, which we could get if we sorted the data and compared them. So that's how you can handle basically, if you have data that's coming in that is not alpha. Now what if you actually have some data that's missing? What can you do there? Well, basically, there's another operator, and that operator is called replace missing. And so if we look at replace missing, replace missing values, okay. And so I could come in here, and again I'd have to put it in the stream of data. It's flowing here, from out to here to here. And so if I want to replace missing data at some point before it gets to the clustering algorithm, I'm going to have to slip in this operator, and as the data flows through it, okay, we can have various ways of handling it, and in this particular case I'm just going to take the average value. Now, this isn't going to work when I run, alright? potentially it's not going to like it. And let me go ahead and run it. Actually, it did work because there weren't any missing values. But problem with what I had here is if I had a missing nominal value, I haven't yet converted to numeric, and I'd be trying to take an average. And so it would make more sense to take the data and first convert it to numeric and then worry about them handling any missing data. And so this would be a better example if, for example, gender was not actually defined. So that's a quick overview. I just wanted to sort of show you the techniques. I realize for some of you this is very challenging, but I think as you move with and get more experience with RapidMiner, the flow begins to make a little bit more sense. So, but that's it for this video.